Lead me, Lord, lead me by the hand and help me face the rising sun. Comfort me through all the pain that life may bring. There's no other hope that I can lean upon. Lead me, Lord, lead me all my life. Walk by me across the lonely roads that I may face. Take my arms and let your hand show me the way. Show the way to live inside your heart. All my days, all my life, you are my light. You're the lamp upon my feet. All the time, my Lord, I need you there. You are my light. I cannot live alone. Let me stay by your guiding love all through my life. Lead me, Lord. Lead me, Lord. Even though at times I'd rather go alone my way, help me take the right direction. Take your road. Lead me, Lord, and never leave my side. All my days, all my life, you are my light. You're the lamp upon my feet. All the time, my Lord, I need you there. You are my light. I cannot live alone. Let me stay by your guiding love all through my life. You are my light. You're the lamp upon my feet. All the time, my Lord, I need you there. Let me stay by your guiding love all through my life, all through my days. So lead me, oh Lead me.
Mga kababayan, ang pambansang awit ng Pilipinas.
Kayang magiliw, telas na sinakanan, alam ng puso, sa dikit mo'y buhay. Lupang pinirang, tuyaga ng magiting, sa manlulupin, di ka pasisigil, sa nagagang tutok sa simoy at sa langit kong pagaw, ay hinagang tulakawin sa pagkayang minamahal. Ang isang lang at awat mo'y tagumpay na nagtitindig, ang pitong pinagkaroon niya kailan ang kanyang magdidinig. Lumanang araw ng warhagis pagsikra, buhay langit sa piling mo. Ang inigaya na pagkay magkakaki, ang mamatay ng dahil sa'yo.
All right. So, good morning, everyone. A wonderful Saturday. We're back on our Saturday scheduled training to bring you tech talks about our latest solution for our robotics. For this Saturday, our scheduled offering is Arduino Classroom by Gearbox Labs. Okay. And we are very fortunate this morning for we'll be having our international speaker. Later on, we'll be having Miss Maria Isabel Mendiola Ramirez from Mexico. And we'll be having as well Mr. Peter Hydock from USA. And of course, we'll be having as well Teacher John Paul Ubina, one of our certified trainer from I Create Cafe Manila. And of course, we're very fortunate this morning for we'll be having the woman behind the successful programs for robotics, okay? And the woman behind this wonderful program for our loved educators here in the Philippines. We'll be having Miss Maylene Abiba, our President and CEO, to give us an opening remarks.
Thank you, Annalyn. Good morning, everyone. We're all over the world. We have some viewers all the way from USA and all places from the Philippines. Good morning once again, and I just would like to share with you what we have been, Felto has been doing for the past almost a year. And we're so fortunate that we have partners like Gearbox Labs from USA who will be sharing with us some of their new solutions, both which can be used in the home and also for hybrid instruction. So first of all, I'm so proud to say that the Philippine robotics team was able to pivot and make printed 3D face shields during the onset of the COVID pandemic that hit us, as I said, almost a year ago. And we made 1,800 face shields, which we distributed for free to 62 hospitals all over the Philippines. In addition, we also made a Philippine Robotics Lego robot alcohol dispenser, one of the first in the world that we distributed for free again to public hospitals, to seminaries, and to public markets. In fact, I am so pleased to announce that I myself have given the donations to the Office of the Vice President of the Philippines, Vice President Leni Robredo, who she really willingly and excitedly received these alcohol Lego dispensers. Now, in addition, the Lego robot ventilator was also conceptualized and built during the height of the COVID pandemic last year by the Philippine Robotics National Team, led by Dr. Yangos Colleges Incorporated. And this is still being used as an emergency ventilator in an ambulance in the hospital in Bulacan. And as like what we're doing today, we have live webinars, which we hold every Saturday. And this is to highlight some of our programs. And we're pleased to say that in the year of 2020 alone, from April to December, we had a total of 36 live webinars, which we conducted for free. Now, we are also venturing into the virtual robotics. We are one of the first countries, the Philippines is one of the first countries to pivot and engage in virtual robotics. We have signed received a memorandum of agreement from the Department of Education, and we trained over 6,000 educators in the last few months on virtual robotics. And in fact, we have our principals from Cognation Robotics, based in Canada, and Lego Education, based in Denmark, who have supported us for this program as well. And we are one of the first, actually, we're the first country to conduct the first Philippine Robotics Challenge using the Virtual Robotics Toolkit. Now, we are also very active in the World Robot Olympiad virtual games, which was held last year, and it will again be held this year in 2021. And the Philippines, particularly led by Felto Multimedia, is I would say, one of the trailblazers in this competition. So here we are. We also have participated in the World Robot Olympiad, where we garnered a first place, a gold medal, a silver, and a bronze for the creative or the open categories. And we did participate in the Robot Virtual Games hosted by WRO Canada. And we also would like to announce that we are also, as a global training partner of Microsoft, Felta Multimedia has been conducting free remote learning trainings for educators. And for those of you who are interested, please do contact Felta Multimedia so that we can put you in, because the program is only available until March 30, 2021. And as I mentioned, we are a global training partner of Microsoft, and we are pleased to announce also that the Felta Multimedia is one of the leaders in Minecraft education, and we have actually won an award for being the first in APAC, in Asia Pacific, to conduct a national Minecraft competition. And well, finally, on the end stretch is that we do have an offering for robotics technology too. And this is a course which is certified by TESDA, which is the TESDA. So we are TESDA accredited, having a senior moment here. Okay, and we are going to be using the Spike platform and hopefully Arduino as well. And yes, we are in the process. Of course, we have our guest here this morning who will be explaining more about Gearbox Labs, and they have an offering for mini kits which you can use in your homes, and as well as a hybrid education. And hopefully in the future we will be having technical training for both the Arduino and the Lego Education robotics kits. And we do have Singapore Math. So for those who would like to avail of our software, which is for higher math, which is, say, examples are trigonometry, algebra, calculus, and geometry, you can let us know. And we do have a software for this, one of our digital programs. And we also have for language proficiency, which is called UTalk. So if you are interested in learning a language and from the comforts and safety of your home, please do reach out to us, because we do have offerings for this as well. And that's it. Finally, we have the physics simulation laboratory for you to conduct physics experiments at home, just like doing it in the physical world. We do have physics simulation as well as science 3D software, which will make teaching and learning more engaging. So with this, we have a lot in store for you as educators and parents and even learners. And please do stay with us for these coming Saturdays that we have in the months of February. And I wish you first Kong Hei Fat Choi for the Chinese viewers, Happy Chinese New Year, and for all the lovers and actually all the people in the world who are viewing us right now is advance Happy Valentine's Day. Thank you so much, and take it away, Annalyn.
All right. So thank you so much, Miss Maylene Abiba. All right. So we have so many watchers at the moment. So without further ado, let us all welcome. Okay, our guest speaker from Gearbox Lab. We have Miss Isabel and Mr. Peter from Gearbox Lab. Hello, hi guys.
Hi, good
Hi.
morning.
Good morning to you. It's Friday night here from the middle of the
Oh,
United
good
States.
evening.
And for those watching, it's about minus 25 degrees centigrade right now outside.
We'll give you the sunshine. Send you some sunshine.
Thank
All
you.
right, so we actually receiving a lot of inquiry already about Arduino Classroom. So we will
Take it.
be not we will not be wasting the time. Okay, so Gearbox Labs, you can take it away.
Take it away. Thank you, Peter and Isabel.
Thank
Thank
you.
you.
So we're very excited to be joining you today. We want to thank Felta Multimedia for being our partner. They are our exclusive partner in the Philippines. So if you're interested in our work, the mini kits, as Ms. Mylene shared with you, or even our larger kits, which we're going to demonstrate a little bit here today and talk about our process, you can reach out to them and they will get you books and kits and the training. So we're very excited to be a partner with Felta Multimedia. Just a little bit about ourselves. We are a multinational company. Isabel Mendiola.
From Mexico. So I studied these STEM programs in North Mexico, since this area is a very industrial city in Monterrey, Mexico. We were always looking for students with skills in engineering. So what we started doing here was changing these traditional science labs in more engineering. Teaching the students the digital design, the first steps for coding, and the prototyping with Arduino. And years later, we had the opportunity to build a curriculum that now we are using for a specific subject. Now we design projects for chemistry, for physics, biology, environmental science, depending the needs of the school. So we are happy to be here.
We're very excited because we had 5 years and 1,000 students in Monterrey, Mexico, go through this curriculum before we actually put pen to paper and wrote it. So we're very excited by the quality and also the feedback that we've gotten from our current users really across the world with the curriculum. So what we're going to do is we're going to show you some sample projects from the larger curriculum and also from the mini kits and give you a sneak preview. This is the first time in the world we're going to show you some projects from the next curriculum, which is about the Internet of Things. So I'm going to change cameras here and we're going to take a look at the first project here. We're going to go over to our document camera. This project is a color sensor. The color sensor is on the screen right, and then we've added a little TV screen here to show the color that it's detecting. This is a great color sensor. It's one of the projects in the larger curriculum, and what it does is it allows you to detect really up to 1 million different colors. Students program what colors it's going to detect, and then we've added the screen here. And Isabel, why don't you demonstrate? We're going to slip a card in here.
Okay, so this is what our students do. They just put any component that they want to test, and the color will be seen on the screen. They are using these prototypes for chemistry, for detecting colors in vegetables, fruits, plastic. They were using candy, a variety of things. So it's a very, very useful sensor for chemistry.
It's a great program, great sensor to use. Students, we've seen them add to it, and we're going to show in just a little bit, servos, and actually show sorting of items by color, whether they're Skittles or they're M&Ms or candies, that kind of thing. We see this sensor actually used in professional settings to determine the ripeness of apples, oranges, those kinds of fruits. So this is a sensor that you would see also in robotics competitions to determine whether you're going to pick up a red ball or a green ball, those kinds of things for sorting. So it's a very powerful sensor and very interesting to use.
Robotics and chemistry.
So let's take a look at, and we're going to actually show a little bit behind the scenes of our curriculum. We're going to switch projects here. This is the servo project. This is one of the earlier projects in the book. This is also available with a single servo as one of the mini kits for Felta. And this is the Felta kit, the mini kit there has one servo and one potentiometer, as well as the Arduino board. This is a servo. So you can see a left and a right servo. This is the basic for joints in robots. Here we're controlling it with a potentiometer, but you could bring in a joystick. We've got a project where you control it with your voice. We've also seen people use it with flex sensors, where you could put it in a robotic glove and it could emulate your movements in the glove with the servos. And so what we'd like to do is we're going to come back to my screen here and do that. And what I'd like to do is share my computer screen here, because we want to show you a little bit about the process that we go through with this. So we're going to select that and that. And what you're looking at here is the start of the process that we go through with students. We are teaching the engineering design process. And most engineers start with a sketch or a CAD type drawing.
Yeah.
In this case, it's
The digital design. Yeah. So in here, what we do, we first design the project, we do the wiring, and we start typing the first lines of the code. So we are teaching them at the same time how to program this digital design. After that is when they build the engineering prototyping.
So what we're doing here is we're using a free program called Tinkercad. It covers about half of the projects in our curriculum, but it also covers all of the projects in the mini kit. So if you wanted to practice building your project as an engineer would, we would have you start in Tinkercad and build this particular project. As Isabel said, in Tinkercad, it's great because it actually has a simulator where you can enter the code, and then when you're ready, your code is working, you can actually test the project. And I'm going to close my code, and we're going to rotate the servo around using the potentiometer. And we'll rotate the other one. And students love to come into the code and change some of the values and how the servo reacts. Every robot has a different amount of the angles that its joints have to work at. And so we teach the students in the curriculum how to change those values and work with it. This is a great place to practice.
Yes. Yeah.
We don't break anything, and we can make mistakes. And what's great about this simulation is we can actually take the code and bring it over to the actual project and then build it as you saw there. So what I'm going to do is I'm going to stop sharing for a second, and we're going to go back to the physical project. So I'm going to change that. And so here you can see the physical project, but we've got to get that code that we did in Tinkercad up to the Arduino board. So we connect it via a computer, a PC, or a Mac works great. There's even an ability to do it with the Chromebook. And what I'll do is I'll show you how that code looks in the actual Arduino. Yeah, we'll share that screen.
Like that.
All right, here. So here we've got the code actually entered into the Arduino IDE. And what I can do is just with the click of a button, because we've tested it in Tinkercad, we can upload it to the board and have it work. It's, again, a process that an engineer would go through: the digital prototype, the digital testing, and then the physical prototype like we've got here. So that's a great emulation of our process. And what students are doing in our curriculum and with the mini kits is they're building skills. And as those skills accumulate, they can do more and more complex projects. Yeah. So we'll come back here. We've seen students take this project and add LEDs, RGB LEDs. That's another mini kit project. You can buy multiples of them and put them together and do some very interesting things with that. So let's take a look at our next project. This is another project out of the book. We're going to swap out here. And while Isabel's doing that, this is a fun project with students. We're just going to plug it in here. Getting your message out is really important. And let me get that in focus. There we go. So this project is also in our larger curriculum. This is an 8x8 LED matrix. In this particular project, what we're really excited about is this is a little bit more advanced project. You're learning arrays.
Yeah, and was designed for actually teaching math, a little bit of physics. So we are using arrays, we are using binary coding, and a website for designing the emojis, character creator. So that way they can practice how to work with other websites, other simulations, and they can build their own images or emojis like this one.
That's very important to add digital displays to your projects. In this case, we're showing some emotions, we're showing the emojis, but we could put characters, we can put numbers, we can do all sorts of things with this.
Displays for their science fair. We have one that was built with an ASP32, a new microcontroller. So these now they are using not just one LED matrix, but they connected 3 more. So they built a display. So what I have it already connected, so we can show an example of what they have done with a larger LED matrix. Let me see, like that.
Yeah. So
there. Okay. Like that.
So what's exciting about this particular project, it's scrolling a little bit fast there, but this project is using a new chip that we're working with, the ESP. This ESP chip is going to be featured in our next book, which is Internet of Things. You can actually hook this display up through the internet and type your message on a web browser like the Chrome or Edge, and send the message through the internet to this device. And we could hook this up to our internet, give you the IP address of our office, and you could send us a message right here on the screen. It's a pretty exciting project that's coming up in our next book. Back to the emoji project for a second. One of our advanced students is working with us right now. He's connected his matrix to a sound, a microphone, and when he speaks, the emojis change. And he's actually going to put that in a mask, a COVID mask. So when he's speaking, the emojis will change on his mask. So you could get the chance to mash up and change and adapt the projects very easily. So let's show another project out of this book and the next one. So this next project, you start in the current curriculum. This is the robotic car, and we're going to bring that in. I'm going to zoom out here. And this car here, what's great about it is you can program the movements. You can add a collision sensor so it avoids collisions, and so they can see the wheels a little bit. Just for a second there. No, like this.
Just all right here.
All right, so that's the robotic car. That is in the big kit from Gearbox Labs here, and it's not focusing too well, so apologies for that. See if we take that up a little bit. There we go. So this is a great robotic car. We can add lots of different sensors to it. In this case, we've actually added a Bluetooth connection to it, and we speak to the car and can control its turns and its motion. So this is a pretty exciting thing. So we start in our STEAM book, which Felta is carrying, and then in our next book, we add the Bluetooth connection to it. You speak to it through a smartphone, and it will move. You want to demonstrate that?
Try. So this one was programmed only for left, right, and stop. It's just a simple code, so students can add commands to the code. So in here, I'm going to look for the connection in Bluetooth, and I will give the 3 instructions that it has here. Left. Right. Stop.
And you could code that for multiple kinds of movements, but that's a project that you start in our STEAM book, the current curriculum, and advance with adding the Bluetooth. It's the base code is excellent. It's easy to learn, and you can add additional sensors.
Yes. We start with the basic, which is the motion of the DC motors, and then we move this code to voice control using Bluetooth.
Okay. So let's take a look at another project it's in our current book. This is the pH sensor. Isabel and I are both scientists by background. So what's exciting for us is the opportunity to, while Isabel gets set up there, we'll come back to us. What's exciting for us is that, again, we're scientists. We both have been educators. So we want to see things that are both practical to teach, but also valuable to the science classroom. In this case, we've got our pH sensor. This is a great sensor that is in the book, and I'm going to change back to the document camera here. So in this case, this particular project, it comes with the pH probe, and what we've done is we've added the LCD screen to this particular project, and then we've got some liquids we can test, and it will tell us the pH of the liquid very accurately. It's a great sensor to use.
Let me see that. All right, so this one has
There you go.
LCD screen, and in here we will see the values of the pH. In this case, since this probe is protected by a special liquid, this liquid is at 4.9 pH. So what I'm going to do here, I will start testing it in another solution. So let me just open the probe. Okay. Wait a second, because it's already. Something happened here.
There we go.
All right, there. So I already have the probe. and I'm going to put it in a solution of, let's see how many points is going to give me this. So this one, it takes few seconds in reading the solution. This one is a solution of pH of 4. So in here, you can see pH of 4. So the sensor is reading, getting the numbers.
Very inexpensive probe, but very accurate. We're really excited to be working with a company to provide these as part of our larger kits as you get more advanced with that.
Every time we use these probes, it's important to clean them and to use the still water for cleaning the probe. And then we can start using it again. So we can test another one. This one is a solution of pH of 10.
So let's see what we get here. See how accurate it is.
It's gonna start. Let's see. We can reset the project, and then we'll start reading. Sometimes it takes a little bit of time. Let's see. And it's taking time.
Yeah, it's adjusting, it's calibrating to the new solution here. So usually it takes about 2 minutes for it to adjust. Seem to pop up very nicely. So we've got that particular probe and sensor to work with. And while Isabel's talking, switching over to the next project, we'll show the soil moisture.
Soil moisture.
So that's another project that's in our book. What we wanted to share with you is Felta is carrying the mini kits, which are a self-contained project. You get the Arduino board, you get all the parts and pieces to make one of the projects that actually appears in our book. But this is the larger book. It's a 240-page, 25 project curriculum, and that's something that Felta will be carrying, and we look forward to seeing schools and some homes certainly can use this, the entire curriculum. So what Isabel's hooking up here is another project from the curriculum. This is a great one. This is a soil moisture sensor. You look in the under the LCD there, we've got kind of a fancy LCD attached to it this time. But what it does is it measures the amount of water that is in a pot or in the ground.
In this case, yeah. So it's using a soil moisture sensor. And what we do, well, we place this sensor on the plant, and we are going to connect the alarm. It has an alarm here. So it's going to sound, so we'll disconnect. It says time to water your plant. So when we do this, adding water to the plant, the sensor is displaying plant does not need water.
The great thing about this sensor and the project in the book is you can calibrate the sensitivity of the sensor. So if you've got a plant that comes from the desert that needs less water, you can set the alarms and the lights to go off at different amounts of water in the soil. Or if you've got a more tropical plant where you want the soil to be a little bit more moist, you can set the sensitivity to that level as well. So a very exciting project, very practical in terms of what students would do in a science classroom. So we have time for one more project, and if we can show we'll show the light project here. So the next project that's coming up is an LED project, And so while Isabel's moving over to that, this project starts actually in the STEAM Edition book, our first curriculum. This is also something that you can do with the LED mini kit that Felta is carrying right now. They've got those in stock. So you can get a good run at it. But what we did is we added a little bit of magic to it. And so what we did here is we hooked it up to a Bluetooth sensor, and we can speak to it. So what we're doing is in the mini kit, you would learn the base project, how to control multiple LEDs. And then in our next book, you would be able to learn how to add a Bluetooth sensor to it.
All right.
To it. So here we go. So Isabel's going to
do this, and then I have connected my Bluetooth already to my phone. On. Let's see. Blue on. Doesn't want to connect.
It doesn't want to start.
It's not behaving.
Okay, so usually it kicks right in. We tested it right beforehand, but
let's see. On. Yeah, it's giving us a hard time here.
It's a great project. You'll have to trust us on this.
Let's see.
We're going to try one more time
One
to
more
get it time, and then we'll take some questions.
All right, here. Lights on. On.
All right. Well,
it
didn't want to do it today. We'll have to go back and troubleshoot. But that's the great part about prototyping, is it's a great teachable moment with students. I don't know how. I think we're pretty good shape for time. But we wanted to turn it back to Felta here, and maybe we can get it running while we're, if we've got questions.
So I need to find the connection, which is 19.
So,
okay. Is it working now, Peter?
We've got so many Bluetooth devices running in the house that I think it went and talked to the TV.
No problem.
Yeah.
Right. At this point, we would like, okay, we will, if it's okay with you, can you stay on for, or is it too late in the evening?
Right. Oh, it's only 8:45 at night here, so
okay,
happy to stay on.
Because we'd like to conduct our own short training, and then have the Q&A after.
Okay.
If that's okay with you. All right. At this point, I'll pass on the screen for Annalyn to show the actual kit for our participants to see, both the mini kit and the big kit, the classroom kit. Go, take it away, Annalyn. Great job. This is really exciting, Peter and Isabel. We're really looking forward to helping a lot of our educators conduct these experiments in their either in their school or for the students to have it done in their homes. Okay, take it away, Annalyn. I'll see you in a bit.
All right. So thank you so much, Peter and Isabel. We're very much excited for all the project that you've showed to us. We are receiving multiple inquiry already about the product. Now I'll be sharing you the kits that we are carrying under Felta Multimedia. Okay, there you go. All right, I know that everybody is already excited because of all the projects that Peter and Isabel showed us. So I'm going to show you the materials that we are offering under Felta Multimedia. So many of you is asking of what brand are we are offering. So we are offering the Arduino Classroom by Gearbox Labs. Okay. All right. So that's the Arduino Classroom by Gearbox Labs. Okay, in partnership with Felta Multimedia Incorporated. As you can see, the special thing about the product that we are catering under Arduino is it comes with a complete set. Now, let me show you first the small kit that we have. Okay. So this is actually the mini kit that we are offering. Okay. Peter and Isabel showed you already on how you're gonna come up with this mini kit. And at the moment, we are eyeing for a hybrid learning. So technically, for hybrid learning, the teachers that is in charge can use the complete set with curriculum, while the student at home can use the mini kit, the Gearbox Arduino mini kit. And then for testing, we can actually use the Tinkercad. All right. So for all the watchers out there, please stay tuned. For Teacher John Paul Obina will be sharing us later on how we can use Tinkercad together with Gearbox Arduino. All right. So that's the mini kit. And then for the complete set, okay, let me show you the complete set. There you go. That's the complete set. That's the Arduino Classroom Gearbox Labs. And then you Peter and Isabel actually shared with us the different elements that we can enjoy with the set. All right, there you go. So these are the electronic components that we can enjoy with the Arduino Classroom complete set. Okay. Later on, Teacher John Paul Ubina will be sharing us of what are the electronic components that we can use with this Arduino Classroom and what are their functions. Okay. And the special thing about with this Arduino Classroom by Gearbox Lab is it comes with a book with complete curriculum. All right. Okay, so what is inside the book? Okay, so what's the special thing about with this Arduino Classroom offering? It comes with a book that comes with 25 classroom tested project that come with standard alignment, 110 plus project extension. It comes with complete material list. It comes with tested code, just like what Peter and Isabel showed us, and it comes with technical diagrams and photo, and of course assessment for the learners. Okay. And this Arduino Classroom integrates science, technology, engineering, arts, and mathematics. And with this different classroom projects, we can integrate this with C and C+ programming basic. Then we can do digital prototyping, engineering design, and of course, project management. Okay, with this Arduino Classroom, what are the perks? What are the perks that you can enjoy with? It comes with free with website registration, project updates, community ideas, and project submission as well. All right, so with Arduino Classroom, teaching engineering, coding, digital design, and prototyping to the world. Okay, so teachers out there, please stay tuned for Teacher John Paul Obina will be sharing his knowledge to us on how we can incorporate Arduino Classroom Lab and Tinkercad. More and more makerspace around the world are looking to add coding and electronics to their maker education programs. One of the best way to do this is by integrating an Arduino board into makerspace projects and lesson. And we've found out that a lot of maker educators haven't taken the plunge into coding or Arduino because they think programming is scary. All right. So without further ado, to share his skills with us and how we're going to incorporate Arduino Classroom in Tinkercad application, let me introduce one of our master robotics trainer at iCreate Cafe Manila. A round of applause to Teacher John Paul Ubina. Hello, Teacher JP.
Hi, good morning.
All right, how are you?
I'm good, Miss Annalyn.
All right. So, all the watchers are already excited for Isabel and Peter already showed us some exciting projects. So Teacher John Paul Obina will be sharing his skills with us on how we're going to use Tinkercad together with the Arduino Classroom. So without further ado, Teacher John Paul, good luck and please take it away.
Thank you, Miss Annalyn. Alright, so maybe we can begin with this training. So by the way, I am John Paul Ubina, and I will be your trainer for this morning. Okay, so let's proceed. Alright, so let's see and explore what is inside the box of the Arduino Classroom by the Gearbox Lab. Okay, so but for this morning, I will show you the commonly used parts. Okay, so let's begin with the breadboard. So what is a breadboard? So a breadboard is a solderless device for temporary prototype. Okay, from the world itself, temporary, with electronic and circuit designs. So most electronic components and electronic circuits can be interconnected by inserting the leads or terminal into the holes and then making connection through wires where appropriate. Okay. Next, the breadboard has strips of metal underneath the board and connect the holes on top of the board. Okay. Next, please. All right. So if you were to pull up the self-adhesive back of your breadboard, it would look something like this. All right. So if we will remove the self-adhesive back of your breadboard, you can see metal strip. All right. So metal strip is interconnected to each other. All right. So you can see the vertical lines and some horizontal lines. All right. Next. All right. So let's proceed on the jumper wire. So jumper wire are simply wires that have connector pins at each end. All right. So as you can see, meron tayong different connectors. All right. And then meron siyang mga pins at the end of each. So allowing them to connect 2 points to each other without soldering. All right. So without soldering. So meaning you don't need to use soldering iron. All right. To connect it. Okay. So jumper wires are typically used with breadboards. Okay. And other prototyping tools in order to make it easy to change as a circuit needed. All right. So using the jumper wire and the breadboard, we don't need a soldering iron so that we can easy to change a circuit as needed. Okay. So next, teacher. All right. So let's proceed on the resistor. So a resistor is an electrical component that reduces the electric current. All right, so the resistor has the ability to reduce current is called resistance, and it's measured in its units. Okay, so this is the sample of the resistor. Okay, all right, it's a very small thingy here. This is the sample of our resistor. Okay, next. LED. All right. LED is a semiconductor device that emits light when an electric current is passed. All right. So light is produced when the particles that carry the current, known as electrons and holes, combine together within the semiconductor materials. All right. So LED has different colors. So we have green, yellow, red, blue, and white, and many more. Next, please. All right, so let's proceed on the different parts of the Arduino Uno board. So as you can see, there are many hole, many text, USB cable, and so many more. Okay, so let's proceed on the presentation. Next, please. Okay, so let's begin with the power. So there are three types that can power the Arduino Uno board. All right. So number one, we have the barrel jack. So that is the circle thing right here. Here, as we can see, meron circle thing that we can insert direct current power. So the barrel jack or the DC power jack can be used power to your Arduino board. So the barrel jack is usually connected to a wall adapter. All right, just like charging your phone, just like that. So recommended voltage for the Arduino models is between 6 and 12 volts. All right. So wag na po sa sobra si 6 and 12 volts. Bakit po? Usually kapag sumobra na doon is masisira na yung ating board and madadamage. Okay? Next, the V pin. So the pin is used to power the Arduino Uno board using an external power source. The voltage should within the range of 6 and 12 volts. Okay? So the V pin is, you can see the V pin on the GND. Kasunod siya ng GND right here. Okay? That is number 2. And lastly, my favorite part is the USB cable. So when connected to your computer, it provides 5 volts at 500 milliampere. So this is the USB cable or the USB port. Okay? So bakit paborito ko siya? Dahil if you connected the USB cable on the port, it can give power and also you can download the program. Okay? Directly. Okay? It gives power and it can download the program. Next, please. Okay, pins. So pins on your Arduino boards are the places where you can connect wires, construct a circuit, probably in conjunction with a breadboard and some wire. So the Arduino has several kinds of pins, each of which is labeled on the boards, okay, and used for different functions. So let's start with the GND. All right, so GND stands for the grounds. So these pins are used to grounds circuit. Okay, so pag sinabi po natin GND, meaning, para mas madali, meaning it's negative. Okay, so as you can see on the board, there are 3 GND. All right. We have 2 GND on the left part and 1 GND dun sa taas ng ating 13 na pin. Okay? Note. Let's take note. So the GND pins are used to close electrical circuit and provide a common logic reference level throughout your circuit. Okay? Always make sure that all GND of the Arduino peripherals and components are connected to one another and have common ground. Okay? Next, please. Number 2, we have the 5 volts, or this pin provide 5 voltage to the circuit. Okay? So that pin, it can provide 5 voltage. Okay? So di na po lalagpas sa 5 yun, ha? Next. Number 3, we have the analog pins. So analog pins, there are pins for reading analog voltage value from sensor and convert them into digital value that can be read. In Arduino, there are 6 analog pin labeled A0 and A5. Okay, so analog pin, you can insert analog component or analog sensor. Okay? So, dyan lang po siya pwedeng ilagay sa A0 up to A5. Okay, next. Next is the digital pin. So, that is number 4. So, these pins are for both digital input, reading the state of the switch, and digital output. Okay? Controlling the LED in Arduino Uno. So, there are 14 digital pins. So, 0 up to 13. Okay? Next. PWM pins, you may have noticed the tilde. So that is meron tayong tilde sign there. So we have 3, 5, 6, 9, 10, and 11 on the uno. So these pins acts as normal pins. But you can also use for something called pulse width modulation. So they are used as analog output like fading an LED in and out. So later on, I will show you some example. So how to put some light on our LED. Okay. Next, we have the RX and TX pin. So these are serial communication pins used to communicate with other Arduino boards as well as the computers. Okay. Next, please. Okay, we have the reset button. So this button is used to restart the code that is loaded to our Arduino. Okay, when you press the reset button, we can reset the program that we load on our Arduino Uno board. Okay, as simple as that. Next is the RX and TX LEDs. So RX means receive and TX means transmit. Okay, so this LED will give us some nice visual indication whenever our Arduino is receiving or transmitting data on the RX and TX pins. So para saan ba si RX and TX pins? So si TX, if we want to see that our sensor that can transmit data on our Arduino Uno board, this TX light will light up. Okay? So, indicator siya. Same as the RX, pag naka-receive tayo ng data galing sa sensor natin, this RX LED will turn on. Alright? So, RX and TX LEDs are indicator na ibig sabihin is gumagana yung mga sensor na ginamit natin. Okay? Next natin is the pin 13 LED. So what is pin 13 LED? So Arduino Uno has an inbuilt LED connected to digital pin 13. Whenever the pin is high, LED is light up. Okay? And when it's slow, LED is off. Okay, so that is the use of pin number 13. So next. Alright. So maybe I can share screen and let's proceed on the Tinkercad. Alright. So this is the Tinkercad by Autodesk. Okay. So right here, we can create circuits. We can create 3D design, as you can see. Alright. So how to log in or sign up to the Tinkercad? So simply, meron tayong 3 different options. We can sign in by our email. We can sign in by our Facebook, or we can sign in by our Apple ID. Okay? But for me, on my case, naka-sign in na ako. Alright? And I have here different sample designs na ginawa ko. Okay? Next. So, for this training, I will show you how to turn on the light of an LED bulb. Okay? Alright. So I have here ready project, but for the training, I will let's begin with the. Okay, maybe we can start. Okay, so this is the working space of our, let me delete the components. Okay, so this is the working space of our Tinkercad. Okay, so here, dito po tayo mag-add ng mga components like LED, resistor, capacitor, and many more. Okay, so as simple as that, we can drag and drop the components na gusto natin. And right here, on the left part, upper part, we have the rotate. So rotate is for rotating the components. Okay, so we can rotate yung mga components na gusto natin. Okay, next, we have the delete button. So as simply as deleting the components na mali nating nakuha. And then we have the redo and the undo. Okay. Next, we have the annotation. So annotation, we can create comments. Okay, para ma-remember natin na yung project na to is for this project. Okay, halimbawa is LED. So we can add comments para ma-remember natin na ito pala yung dapat niyang gawin. Okay, and then we have the hide annotation. So simply as hiding the comments. Okay, so we can hide the comments just like that. And right here on the right part of your screen, we have the basic components. Okay, so meron din pong all, basic Arduino, microbit, circuit, and many more. Okay, but for the meantime, we can use the basic components. Alright, so lahat po ng basic components is right here sa ating right part. Okay. Next, right here naman, we have the code. So this code, this tab will show you the codes. Okay. So meron tayong text-based and we have the blocks-based coding. Okay. So let's begin with the simple project. So this project is lighting an LED. Okay. By the way, we can rename our project by double-click the project name and we can rename it to anything we want. But for my case, I want to rename it to LED. Alright? So now let's grab a board. Okay, so as you can see, I have here breadboard. Arduino Uno board. Next, we need small breadboard. One resistor and one LED. Alright, so paliwanag ko lang how we can read the breadboard. So as you can see, earlier, I mentioned that sa breadboard, meron siyang interconnected connection. Okay? So meron siyang sa likod ng ating breadboard, we have metal strip na horizontal and vertical. So para saan ba yung mga metal strip na horizontal and vertical? Now, if I put my cursor right here on the positive sign, as you can see, it's connected hanggang dulo. Okay? So from this hole until you reach the end of this hole, it's connected. Okay? That's why meron tayong metal strip under. Kasi connected siya hanggang dulo. So, same as the negative. Okay? So, from this point until you reach the end point, connected siya. Okay? Same as this. Connected and connected. Next. Makikita natin on our board, there are some numbers. 1 up to number 30. So, para saan ba yung mga numbers na yan? So, ibig sabihin, para makita natin na itong line 1, tawagin natin siyang line para hindi tayo malito. Line 1 is connected hanggang letter E. Line 2, same as that. Line 2 connected hanggang letter E. And then meron tayong mga letters A, B, C, D, and E. So same as this. F hanggang J is connected. Okay, so ganun po yung pag-read ng ating breadboard. Okay, so interconnected siya to each other. Next. Let's grab some jumper wire. Meron tayong wire dito. So, how to add wire? So, just click lang dun sa ating mga holes or dito sa ating GND. So, on my case, I will start on GND. Okay? So, GND, I have here wire na already. And ilalagay ko siya sa aking negative part. Okay? So, GND, as I mentioned earlier, GND stands for negative. Okay? So, nilagay ko si negative dun sa ating GND. So, by the way, we can change color pala on your desired color. But on my case, I want the GND to turn into color black para ma-remember ko na yung GND na yon is negative. Okay? Para madali po nating matandaan. Next. Let's add LED. Okay? So, rotate ko muna siya. I want to rotate my LED. And see, cathode means negative. Ilalagay ko siya doon sa negative part ng ating board. Okay? Kasi si cathode is negative, right? Hindi ako nagkakamali. Negative si cathode. Next. We add ulit wire. So, the anode is positive. So, add natin si wire here sa number 6. Okay? So, pwede naman kahit sa number, add. Sa letter D. Basta line number 6. Kasi ang sabi ko, gaya na sabi ko kanina, connected siya from each other. Okay? Next. Grab natin sa resistor. Connect natin siya dun sa line 6. And connect natin siya dun sa line 6 sa kabila. Okay? So, ibig sabihin, connected siya na siya to each other. Now, let's grab a wire from line 6. And let's connect this one into pin number 13 to our digital pins. Okay? So, bakit pin 13? Ba't sa pin 13 ko siya ginawa? Pin 13 kasi is the basic part. Kapag nag-add tayo ng project, automatically, pin 13 agad yung lalabas. Alright? So, makita nyo po dito ang ating code. Pin 13 agad. Okay? Pwede naman siya nating baguhin. Pwedeng pin 12, pin 5. So, depende po sa code ninyo. Okay, I think I am ready na to simulate my LED. Okay, so as you can see, the LED is blinking, okay? So, on, off for certain seconds. But, paano ba siya gumagana? Okay? So, let's start by doing the template. So, ano ba yung tinatawag nating template? So, si template is, yun yung pinaka-template ng ating programming. So, ano ba yung template natin? So, ang template natin for this activity is we have the void setup, open and close parenthesis, up, close, next, open brace, and syempre ang ating closing. Next, we have the void loop, open and close, open brace, and close. Alright. So, ito yung tinatawag nating template or sketch. Okay? On Arduino programming. So, pag ni-run ko yung code, so as you can see, walang nangyayari. Bakit walang nangyayari? We need to put declaration code doon sa ating programming. Okay? So, paano tayo magde-declare? So, ganito lang po. For the meantime, ipapaliwanag ko what is void setup and what is void loop. Okay? So, si void loop, start tayo with the void setup. Void setup is once lang natin gagawin. Okay? So, dapat po nandito siya inside the open and close braces. So, bakit dapat nandun siya sa loob? Kasi po, kapag wala dun siya sa loob, hindi gagana yung ating code. Okay? So, si void setup, once lang natin siya gagawin. And dun tayo nagde-declare and nag-add ng mga variable natin. Okay? Next. Next natin is the void loop. Okay? So, from the world itself, void loop. So, ibig sabihin po is, void loop, ulit-ulit niyang gagawin yung code na nandito sa ating void loop. Okay? So, dapat inside siya ng ating open and close brackets. Okay? So, next. So, let's declare yung ating output. So, ano ba yung ating declaration for this LED? So, our declaration is pin mode (13) output. Okay, so bakit pin mode 13 output? Pin mode dahil ang ating pin is connected to digital pin 13. Okay? So what if nalipat ko siya dito sa ating digital pin 12? So ibig sabihin, we need to change the declaration. Okay? So pin 12 ibig sabihin, papalitan lang natin yung dineclare natin na code dito. Okay? But on my case, gawin ko muna siyang pin mode 13. Okay. Okay, next. Bakit output yung nakalagay dito? Output kasi dahil the component is nag-i-emit ng ating light. So, ano ba yung gamit nating component? Siyempre, ang component na gamit natin is LED. Okay? So, ibig sabihin, nag-i-emit siya ng light. Okay? Next. Bakit tayo merong semicolon sa dulo? Semicolon dahil, ibig sabihin, end line. Okay? End line, ibig sabihin, wala na siyang kasunod na code. Okay? Ibig sabihin, period. Period. Okay? So now, meron na tayong void setup. That is the pin mode 12. 13, sorry. Let's clear this one and make it 13. Tapos, let's add commands ulit. So, let's add digital, right? Open parenthesis, 13, and high, close, and period. Okay? So, bakit digital write 13? So, digital write 13, so stands for the pin number 13. So, bakit naman high yung nakalagay? Bakit naman high yung nakalagay sa ating code? So, high, on the Arduino, high means on. Okay? High means on, and low means off. Okay? All right, so maybe we can try this code. So let's start the simulation. All right, so as you can see, the LED is turning on. Okay, because of my code. So pin mode 13 output emits light, digital write 13 on. Okay, so what if I want to, gusto ko mag-add ng off. So paano natin siya gagawin? Okay, so let's add delay. So it depends kung how many seconds you want to delay the light. So on my case, I want to use 1,000. So 1,000 is 1 second. Okay, delay, open and close, and period. Okay, we use semicolon for period. Okay, next. By the way, we can add comments just like the annotation dun sa ating working space. So how to add comments? All we need to do is a backslash comment. So that is wait for 1,000 milliseconds. Okay, 1,000 milliseconds. So milliseconds is equivalent to 1 second. So ang tanong dito, nakaka-apekto ba siya sa ating code, si comment? Ang sagot po dyan is no. Bakit? No po dahil nag-add lang naman tayo ng comment eh. Nag-add lang tayo ng note. So wala siyang kinalaman. Basta meron tayong nilagay na backslash. Eh what if binura ko? So pag binura mo yung comment na yon, automatically, magkakaroon siya ng wrong sa ating program. So that's why we add double backslash. Okay? Next. So meron na tayong pin mode 13 output, digital write high means on, and we added delay for 1,000 milliseconds. Next is, syempre, we want to add low, di ba? Or off. So let's write digital write, open parenthesis, 13, and our digital pin is 13, and off, close parenthesis, and period. Okay. So next, let's start the simulation. So let's see if this code will work. Okay. So dapat mag-on siya ng 1 and mag-off ng 1. Okay? Ulitin po natin. So as you can see, the LED is turning on and turning off. Okay? So nakita niyo yung ibig sabihin kanina na si void setup is isang beses niya lang gagawin yung code na to. Excuse me. Okay. So si void setup is one time niya lang gagawin. Okay? So what if I want to use it unlimited? So ilalagay ko yung code na to dito sa aking void loop. Okay? So let's write the code. Let's delete this one. Later on, by the way, later on, we will do it on our actual Arduino Uno board. Okay? Digital, right? Open parenthesis. What is our digital pin? That is 13. And we need to make it high, close, and period. Okay? Next. Let's add delay. Open parenthesis. How many seconds or milliseconds? Period. Digital, right? Low, close parenthesis, and period. And lastly, delay, 1,000, close parenthesis, and period. Okay? Alright, so as you can see, yun yung pinagkaiba ni void setup and ni void loop. Okay? So si void loop, kung makikita nyo, ulit-ulit nyo yung ginagawa, yung code na nandito sa ating void loop. Alright? While si void setup, isang beses niya lang ginawa yung code na nilagay natin kanina. Okay? So, yan po yung difference ng void setup and ni void loop. Okay? Okay, so maybe we can go with the actual Arduino. So, bakit ko ba ginagawa tong Tinkercad and then si Arduino Classroom? So, dahil nga pandemic ngayon, hindi tayo makalabas ng ating mga bahay and we have online classes, right? So, we can use the Tinkercad para doon na tayo magtuturo. And we can use the Arduino Classroom Gearbox Labs para sila yung mag-a-actual. Okay? Okay. So, let's proceed on the actual okay, let's proceed on the actual Arduino Uno board. Okay, all we need, ang need natin is the board, syempre. The breadboard, LED, resistor, and yung ating jumper wire. Okay? Next. So let's insert the USB cable to the port of the Arduino Uno board. And we need LED, the resistor, and the jumper wire. Okay. So ang first step is we need to put the jumper wire doon sa ating pin number 13. So, yun yung example natin. So, make sure na connected siya dun sa pin 13. So, let's count. 8, 9, 10, 11, 12, and 13. Okay, so as you can see, the light is turning on. So, indicator siya na gumagana yung ating digital pin 13. Okay, next. Breadboard. So, si digital pin 13 is color white and let's connect it on line 6. Here. Alright. Kung makita nyo, meron siyang mga numbers. So, it's connected na on line 6. Next natin is the resistor. So, si resistor is controlling the electric na pumapasok sa ating board para hindi masira at ma-damage. Okay. So, let's add resistor. So, it's connected on line 6. Let's connect it. And, ilagay natin siya sa kabilang part ng line 6. Okay, so as you can see, it's connected na, interconnected na to each other. Ulitin ka lang ha. So this wire is connected to digital pin 13. We connect it on line 6. Also, the resistor is connected to line 6. Next, we have the LED. Okay? So, yung ating cathode, that is negative. Let's put this one on the negative part or dito sa ating GND. Okay? So, sa ating board. So, let's put it on line 5. Dahil walang line 6 dun sa ating board, let's connect it on line 5. So, also the resistor. Also the pin, digital pin. So, let's move it on the line 5. Okay, so as you can see, it's connected na on line 5. The LED, we put it on the negative. And the anode is connected to line 5. Also the resistor and the pin number 13, jumper wire. Okay. Next, we need negative. Okay, so I use color black jumper wire. So I need to connect it on the negative part of our board. So this is the color blue part. So let's connect it on the negative. Syempre, the end wire, yung wire na to, we need to put it on the GND. Okay, so that is ground. Okay, so pwede natin siya dito sa ground na to or dito sa ground sa kabila. Pero mas gusto ko siya dito banda sa left side. Para hindi na kadikit yung digital pin. Okay, so as you can see, it's connected na on the GND. Alright. So maybe I can share screen again. Okay. So now let's add sketch ulit and template. So ano ba yung ating template? So that is the void setup. So void setup, open and close parentheses. We have the opening brackets and the close. Next, we have the void loop, open and close, open brackets and close. Okay, so let's declare our pin mode. So our pin mode is pin mode 13. Okay, so this is the tricky thing pag nagko-code tayo. So, the Arduino programming is case sensitive. So, ibig sabihin, kung ang nilagay mo, ang dineclare mo is John Paul, malaking J, yun lang yung babasahin niya. Okay? Pero pag ginawa mo is all caps, this is wrong. Mata ng ating mga mata, same lang siya na John Paul, but on the Arduino, magkaiba siya. Okay? So, dapat po, susundin natin yung malalaki at maliliit na mga letters. Okay? So, let's change the pin mode into big M. Okay? Pin mode, open parenthesis, siyempre output kasi nag-i-emit tayo ng light. And period. Next. Dahil nakapag-declare na tayo sa void setup, we can add commands dun sa ating void loop. So digital write 13 high period. Delay how many seconds, close parenthesis, period. And digital write. What is our pin mode? Our digital pin 13, quit, and low. Means off and period. And then lastly, we have the delay, close parenthesis, period. Okay. So next, let's check if the Arduino is connected, okay, by going here sa tools and port. Let's choose our serial port kasi pagka iba-iba yung port na nilagay natin, iba-iba rin yung ating COM port, okay? So for on my case, connected siya sa COM port number 7. Okay? Alright, so let's try to run the actual Arduino. Okay? So as you can see, ang ating Arduino is turning on and turning off. Okay? So ibig sabihin, yung ating Arduino and LED, resistor, and jumper wire is connected. Okay? So ibig sabihin, si ating LED, jumper wire, resistor, and our boards is connected. Okay? And it working properly. Okay? So what if balik tayo sa ating Tinkercad. Okay. Okay, so this one is the sample of the dimmer na tinatawag natin. Okay, so we are done with the lightning and LED. Okay, so now, let's proceed dun sa ating dimmer na tinatawag. So si dimmer, siya yung, kung mapapansin nyo sa mga hotels, mga kwarto, meron tayong dimmer na tinatawag. So kung mapapansin nyo, if I rotate the potentiometer, the LED will turn off. Okay? So medyo mahina yung ilaw, papalakas. Okay? So yan po yung gamit ni potentiometer. So ito yung mga nakikita natin sa mga hotels, mga house natin, just like that. Okay, so paliwanag ko lang kung anong nangyari dito sa ating project na to. Okay, so as you can see, dahil meron tayong potentiometer, nag-add na tayo ng 5 volts. Okay, so si 5 volts is, we can supply, the board can supply 5 volts dun sa ating potentiometer. Okay, so nag-add tayo ng wire, right here, and connected siya dun sa ating terminal number 2. Okay, so papaliwanag ko lang po how it works ha. Next, the wiper, that is the color green, so it's connected dun sa ating A5. So ano ba yung sinasabi ko kanina na analog in, yung mga analog pins. So analog pin po, dun po natin i-insert yung ating mga sensor. Okay? So the wiper is connected dun sa ating A5, which is the analog pin. Okay? And the terminal 1 is connected dito sa ating negative sa ating breadboard. Okay? So let's change the color para hindi tayo malito. So color black, we can make it black para ma-determine natin na that is negative. Okay? Next, nag-add tayo ng LED and it's connected dito sa ating line 16 and it's connected dun sa pin number 11. Okay? Next, we added na rin yung resistor. Okay? So that is the cathode. Okay? So connected sa cathode and then lumusot siya dito going to the negative part ng ating board. Okay? And lastly, syempre mag-a-add tayo ng ating GND which is the ground para meron tayong negative supply sa ating board and then sa ating breadboard. Okay? So let's start the simulation. So as you can see, when this potentiometer is right here sa ating left part ng ating skin, at kapag inikot ko siya, dahan-dahan siyang lumalakas. Okay? So, when I turn it back, ang ilaw natin is going low. Alright? So, that is the use of our potentiometer and LED light. Okay. So, let's sneak sa ating code. So, nag-add na tayo ng integer, input A5. So, ano ba yung integer? Integer is a variable, okay? Integer, input, saan tayo nag-declare? Sa ating A5. Integer LED is connected sa ating digital pin number 11. And our integer value is 0. Okay? So, declare natin ulit si void setup. So, ano yung pin mode natin is LED and output. Okay? So, output, ibig sabihin, mag-i-emit tayo ng light. And nandun sa ating void loop is the value. The value is 0 kanina. So, analog read. So, ano ba yung nire-read ni analog? Ang nire-read ni analog itong potentiometer. So, ibig sabihin, kapag lumalakas, yung value niya, kanina 0, ibig sabihin, lalakas. Okay? So, going here, from this point, going here, papataas din yung value ni potentiometer, which is connected sa ating analog pin. Kasi analog read nakalagay dito. Okay. Analog write, LED, value is 4. Okay? So, let's start the simulation ulit. Going low and going high. Okay? So that is the use of the potentiometer. Okay? So thank you so much for this morning. I hope you learned something from me. And I think, Miss Annalyn, are we good?
All right. So thank you so much, Teacher John Paul Obina, for sharing that wonderful topics. As I mentioned, Ma'am Maylene, we are actually preparing for a hybrid learning for upcoming 2021-2022 school year. So I guess the kit together with Tinkercad is a great platform in order for us to go proceed with our programs.
Yes. Actually, while JP was conducting his training, there were a few schools already doing their their experiments, and they were showing it to me. So it's really nice. Some of the students are actually doing the Tinkercad either virtually or they have the actual kits. And I believe, look at this, Isabel and Peter finally have their project about the lights.
We had
Can you explain before we do the Q&A? We have a few minutes.
We had
Go
two
ahead, Peter.
Bluetooth devices
Thank you,
on.
JP. Yes.
So Isabel's talking to the Bluetooth device through her smartphone, and go ahead and demonstrate. So those are all our devices here in the house.
Off.
Screenshot ka daw. Teka lang.
Blue on. Green on.
Cool.
So this is the base programming for Siri and Alexa, all of the smart devices that you might find in your house, the same kind of coding. And that's coming up in our next book.
Yellow on.
Great. It's like those voice activated homes, those smart homes.
Yep.
Yeah, lights on, lights off.
Yes.
But this
Great.
is just the base. We have already a house. We have different projects with different commands already. So, yeah.
Yeah, we're excited about that. But thank you. You guys did a phenomenal job talking about Gearbox, Arduino Classroom.
Okay, great. Okay, it's really nice to see that we are already venturing into the IoT using the Arduino Classroom. Right, Annalyn, let's proceed with the Q&A. We have
All
a few.
right.
Yes.
Okay, so
First of all, do a shout out to all the schools we have and the coaches, our robotics coaches who are watching us right now. First, I'd like to do a shout out to Miss Genevieve Pilar, Miss Jen of De La Salle Zobel, who's watching. Hello, good morning. And also Ronald Koss, who is also one of our graduates of the Felta Techbook Academy for Robotics Technology. They're watching.
yes, actually, ma'am, DepEd, a shout out as well to DepEd Bohol team. They are also watching with us. We also have watchers from Nevada, USA.
Yay.
Actually, it's a great day today for we able to see different projects for this Arduino solution. Guys, for your information, before we proceed with the Q&A, because Peter and Isabel will be joining us for that section, those simple basic activity the teacher JP shared with us was based on the book and curriculum that we offer. All right. So for teachers out there who want to start up with your program for STEM, this is actually a good product for we have here a complete curriculum that you can use for your programs. All right. For inquiry about that, you can directly message us at Felta Multimedia Incorporated. All right. So again, welcome Peter and Isabel. We're very happy to see all the project that you've shared with us. We have here sets of questions. We'll be sharing you around 5 questions. Is that okay with you?
Shoot
All
away.
right. All
Are you
right.
still
Teacher
awake?
Karen.
They're still awake.
Yeah, we're here.
Okay.
Actually, our sets of questions here are mixtures from students and teachers. So right here, we have question from Owen Justin Gocheco. He is a student, so he is asking of what OS are supported by Arduino Classroom.
That's a great question. It's multiple OSs. You can do it on the Windows, the Mac OS. There's a Chromebook app that is available. There's a caveat, the Chromebook app, there's a little bit of a subscription to allow you to upload to the board. So they get you with a little bit extra money. There's also a Linux version. It's
All
really
right. Great. And additional question to that, is there any device requirement that the students or the educators need to invest in?
beyond having the desktop or laptop computer. No, everything else, Tinkercad, the programming IDE, that's all free for download.
All right, that's great. All right, so Owen Justin Gocheco, I hope that we able to answer your question. Now let's hear it from the other teacher. Okay, one of our members as well. So I'm an absolute beginner. Is there any program that you can offer virtually? I guess I can answer that questions. In Felto Multimedia, under Pelto Techbook Academy and I Create Cafe Manila, we do offer workshops. So technically, Arduino Classroom is one of the offering that we want to roll out this coming March. So watch out. All right. So next question, Teacher Jobin. All right. So this is from an educator for Peter and Isabel. Wonderful project demonstration. Is there any existing standalone or permanently in ground soil moisture sensors with an installed GSM module for outdoor use?
So yes, you can build with the Arduino exactly those all of those parts and pieces. GSM being cellular connection. We would recommend probably a different soil moisture sensor that could be permanently in the ground. They don't rust, they don't oxidize. Um, and we're actually covering several of those projects in the next book. So it talks to the internet and you can see just how wet or dry your soil is. So yes.
All right, that's awesome. Because here in the Philippines, we want to promote robotics in agriculture as well. So we find that project very helpful to us. There you go. More question? All right, Teacher Joven, more question, please.
More questions? Okay.
Last two questions. I guess we have here Lorenzo Marquesini. I would like to ask you a question about a project I'm doing.
He must be a student. Okay, he can contact Felta Multimedia. We have teachers and trainers who can help you. I am assuming he has a project that he has to submit. All right, we free tutorials as well.
Yeah, yes.
He has to do some work. He should not hand over his project directly to us. He has to do some work as well. Thank you, Lorenzo.
Right. So, Annette, I think last two questions for Peter and Isabel. This is one of our actually trainer from Felta Multimedia. Is there any programming for beginners like block code?
Yeah, there is.
There is,
Yeah.
but,
Oh,
So within the Tinkercad, Tinkercad has the ability to program in blocks for the Arduino. So it's a great transition from scratch programming to Arduino. You can start working with blocks before you transition to the C++.
all right. So that's cool. Actually, Peter and Isabel, I mentioned that under Pelto Techbook Academy, we are catering workshop. So for our regular members, we are catering robotics for elementary student. We actually started the program from age of 6 years old. All right. So thank you for that wonderful information. And I guess one more question. I think this is one of the most important questions that we need to answer as well. For a face-to-face learning, okay, usually the usual setup here in the Philippines is we have our robotics laboratory wherein all the materials that we have is in there. And then there are scheduling for our different classes. And then in regards to that, another question is, do you have any tips for carrying your Arduino set, especially if you are using it for our regular classes?
Yeah, sanitation procedures.
How old is parts are
So yeah, we have Arduinos, for example, the pH sensor. This one I have 6 years with the sensor, with the LCD, the microcontroller. I mean, they last. That is the reason that we started using Arduino, because the pieces are really strong. And basically what I have been replacing are the cables. So
The cables.
But the parts that we've included in the kit for Felta, these are ones that we've used for 5-6 years in Isabel's classroom. 1,000 students have played with them, and they're really excellent for classroom.
But about for sanitation, can you give us some tips how we will be able to sanitize the kit since a lot of students will be using it?
So just the standard sanitizers will work. Make sure that they get dry. I would use something that's got a little bit of alcohol in it to clean. And as long as everything's dry afterwards, you're in good shape. These materials are super plated or gold plated or non-oxidized kinds of metals.
Okay, so it's safe for us to use alcohol.
Yeah.
It will not erode
Yeah.
or not be compromised. Great, great. Oh, that's good to hear.
Yes. Okay, so for our watchers out there, as you can see, the Arduino Classroom is a good investment for our STEM program. We have one last question. Is that okay?
Sure.
Okay, I'm very happy because there are so many students who are watching us right now,
And
they're
educators.
yes. Okay. One last question from Princess May Pacheco. Which board can I use in Tinkercad?
Yeah, well, right now we're using Arduino Uno, but
Mhm.
recently was added the microbit. So those are the two that Tinkercad is using. Yeah.
Okay.
And
Okay.
the Uno really emulates very well the Nano and the Mega, some of the other Arduino boards. So it's a good substitution for all the other boards you might want to use.
Okay, that's great. So, for proper investment, we encourage everybody to avail the Arduino Classroom offering for it gives you a complete package wherein it will technically offer a great success for your program. So, in line with that, any final words, Mama
Words
Yin?
from Peter. Well, first of all, I'd like to thank Peter and Isabel for staying up late during this cold time in the USA. To be with us, our viewers, we're really very honored to be your partner here in the Philippines, and we'll continue to be you're very active in either webinars or tutorials and trainings, either hybrid or virtual. So thank you so much, and also for the Felta team, I Create Cafe Manila team. It's a Valentine's weekend, and we're still working and doing these webinars because we do love what we're doing and helping our educators. Okay, may we hear from Peter and Isabel?
Well, we wanted to thank you for the opportunity. Felta, you've been an amazing partner for us, and we're very excited to be working with you and then to all of the teachers and students in the Philippines. We really encourage you. Felta, you've done an amazing job learning our program, and so you are expert. It feels good to see what you've learned and done with it.
Yeah, yeah. And we are so happy to be here and to share our experience with you. And yes, always, I always having fun being here.
We want to share actually a really interesting piece of news. We had one of our student group compete in a contest here recently. They won $110,000 worth of robotics parts
Fantastic.
that's here in the U.S. using our curriculum. So it's exciting to see. It's a really high quality product that can lead to great success. So thank you.
Great. And speaking of competitions, well, I'll be shooting the gun a bit, but we are going to be organizing a STEM online virtual competition. This is in partnership with Department of Science and Technology. So we'll give more details
Excellent.
for the schools who are viewing us right now.
So thank you. Thank you very much.
Appreciate.
Thank you very much, and advance happy Valentine's Day, and belated happy Chinese New Year for our viewers. And have a lovely day and a lovely weekend, everyone. Thank you, Annalyn. Good job as always. Okay, happy Valentine's. Kung hei
So,
facho.
thank you so much, Miss Millie Aguilar. Thank you so much, Peter and Isabel. Okay, good night. You can now take your rest. Okay. And for our dear educators, thank you so much for watching with us this Saturday. Stay tuned for next Saturday. We will be introducing our new solution that can be used for a multi-platform language learning course, and we call that UTalk.
Utah. And our principal from London will also be joining us very early in the morning in London at that time, but they will be joining us also next week. Okay, so thank you so much. We have a lot in store. And everyone, let's go get our Arduino Classroom mini kits and our classroom kits right now. Thank you. Have a blessed
Thank you,
weekend.
everybody.